Alrighty, good morning. I am back to work on my game engine. Yesterday I had on stream set up include files in GLSL, which is going to be critical for the development of systems that render. Basically, I need a way to standardize the boilerplate code like uniform buffer declarations that are going to be used by systems. So now instead of having to write out, in every single shader, write out the EP per camera and EP per draw uniform buffers for the, view projection, model view projection, and camera position data, I just write include enterprise.glsl, and it will my GLSL parser will go in and substitute this line for the contents of this file using my virtual file system. So yeah, there's a few outstanding things to work out, but the gist of it is correct. One of the first things that I want to address has to do with the working directory. The location of certain shader files is going to be kind of a little problematic to manage, and I think I've decided upon the solution that I want to use. For the first part of the stream yesterday, I set up a system where in a custom post build step, Visual Studio would invoke robocopy on the command line to copy over and mirror the contents of a folder and put it in the directory that the executable exists in. The idea was that if I take, and I'll pull it up in here, if I take and make the working directory, did I take it out? If I take and make the working directory something, make the working directory the location of the executable, then I could just leave the path the same when I'm shipping a game versus when I'm debugging. So heading back to my enterprise project, the idea would have been that when I go to build my binary as a post-build step, alongside the binary, the folder containing the engine shader files would be copied over from their location in the engine library source. And then while I'm debugging, the paths that lead to just slash engine shaders would be the same path as when the game is installed, when it installed in the program files folder. The big problem with that is that it'll only complete the post build command will only complete when I'm actually recompiling my project. So that makes it so that if I am working on the GLSL file itself, like if I go into a GLSL header file and I'm working on it and I want to test it, I would have to literally go in and go right click, project only, rebuild only sandbox, have to actually recompile the project, and then at that point it would copy over the changes, which is not a very conducive workflow. Granted, this isn't going to affect anybody but me, because the shaders that are affected by this move are located in the engine library, and that's something that very few people will ever touch, assuming that other people work with this engine. But for my purposes, it's a bad enough problem that I'm going to need to have a different solution. So what I've decided to do was to change to using a command line option. So we're not doing a post build command anymore. I'm just going to go ahead and scrap that. Let me close out of Visual Studio. And I was doing a lot of hacky changes directly in the solution and the project files to test out a couple of different scenarios before the stream. So I'm just going to go ahead and delete my solution files, my project files outright, and then we will start from scratch. So now we're back down to just the source. And then I would go to scripts, pre-make 132, run the script to regenerate my solution file. And so now we should be back to standard implementation or standard project. Now, when I go into right-click, go to properties, go to debugging, something that I have been doing while working on the engine is supplying command line arguments to the program, content dir, and I specify the content directory, and then data dir, and then I specify the location of the redirected data folders. So I usually will redirect to here, the content subdirectory in my sandbox project for the content, and then I would redirect to /data for the data directory. And that's been working okay. The idea is that with those set, when I go to run the program, if I go to file.cpp, here we go. The program will, at launch, check to see whether these commands were specified, and if they were, we will use those paths for reading and writing files for the remainder of the runtime. And if they're not specified, then we do the platform-specific stuff. So we got to set platform data paths on the Win32 version of this file, and actually invoke the I think it's sh known directory or known folder. Oh, come on, IntelliSense. All I did was hit Control-click on the link on the yeah. So it would like actually use sh get known folder path to actually get the app data folder, to actually get the save games folder, and so on. I think I'm going to do the same thing for the shader, include files. The reason why I was kind of hesitating to do this for that stuff is because of Xcode, to be honest. It is totally possible to, in pre-make, I'm just building the library for the first time because I cleared out the build folder from before. It's totally possible in pre-make to specify command line arguments. It's just like, I'll do it outside of the filters here. It's just like debug args, I believe. And then you can do multiple command lines here if you want. So I could do content dir and specify here, and I can actually specify based off of the project name. So if somebody was using the script to make something that's not called sandbox, it would actually redirect to the correct location. But the problem is that this does not work in Xcode when you're building an Xcode project. That's just a limitation of pre-make. What do we got? Oh, did I leave something not working in my shader file? GLSL. Yeah, this stream I'm just going to be spending the time handling a couple of bugs, like this one. That's interesting. So it's not actually. Oh right, yeah, it's not loading the. Yeah, this is exactly what I'm talking about. It's not loading the include line because it's not able to find engine shaders.enterprise.glsl because the working directory right now is the wrong directory. But anyway, going back to what I was talking about. It's totally possible to in the pre-make file specify debug stuff, but that only works for Visual Studio. So I thought it was okay to use command line arguments if the developer was, privy to them and they can pick and choose where they want to set the stuff. But I thought it was kind of a little much to say, okay, when you go to setup, you have to locate a whole list of things to specify to your command line just to debug normally. So I spent some time researching to see if I could identify a way in which I could specify go in as after Premike builds the Xcode project for me to go in and manually, let me stop the debugging there, manually fix the command line myself. And it appears to be that there is a way. I think that the problem is that Premike, which frankly has just got limited support on Mac, as it turns out. It's not getting regular updates. It doesn't ever touch scheme files. So within your Xcode project, you've got schemes, and schemes they describe your build process. So you have you can set up which thing you build, whether you're using the Xcode terminal or the external terminal, what your working directory is and things like that. But that's in Xcode by default. That is a per user thing, and so Premike's solution is to just not set up anything that goes in that file. But it turns out that it's totally doable. You just need to script it correctly, and I think I've got a good picture of how I'm gonna script it. So I've decided that I'm going to actually do command line arguments as part of the Premike file. So it'll actually spit out a project with the correct command line arguments in Visual Studio. And then what I'll do is in my scripts folder, after I've got this working on Windows, I will go into the script for invoking Premike on Mac, and I'll just add some additional lines down here to set up a scheme file, which is not a small amount of work, but apparently it's a lot more doable than I had originally thought. And so that way, when somebody goes to run the script, they just double click on their Premike Mac Xcode 11 command, and it'll just create the project file with the schema already made, so that you can just click the play button or press the Command R and run it, and it'll just automatically set it up with the correct directories. So for today, I'm going to implement that command line option so that it doesn't matter what working directory you have. And so when you get to the installed application, it will correctly reference the correct location as well. So for starters, let's go back to this guy, and I will add, oops, that's the wrong one. I've been switching back and forth between Mac and PC today, and whenever I do that, I accidentally switch between Alt-Z and Command-Z, because Alt is where my command is on my Windows keyboard. But anyway, here we go. So underneath the platform-specific build settings, I'm going to be doing the command line stuff. So I think it's debug args, and then I can do multiple strings. So the first thing I'm doing is the content directory redirect. And then the second one will be data dir redirect. So I do need to stitch together the correct path here. So to do that, I'm going to reference the stuff I had done below. Well, this has to be in reference to the working directory, which on Windows is defaulted to the project directory, so sandbox. This folder would be the working directory. So I would need to actually just go to content. So that's the simplest redirect there is. I don't know if I'm going to. I guess doing this will enforce that people use content and data alongside source. So old is unrelated. That's just stuff that I don't use in content anymore. And resources is for the macOS plist file. But yeah, I guess this kind of does enforce a scheme, but it's not a bad scheme to say this is your content directory, this is your working data directory, and then this is actually the source controlled source code. So I guess I'll go ahead and just do that. The data directory, though, yeah, I guess we can just say data. I'm assuming that this holds. The idea behind the command line is that people could specify all kinds of other locations. If this is not specified, then content dir will still actually be right next to the executable, right next to the executable /content in the program files folder. But the data directory is always in a separate location. So if the data directory is not specified on Windows, it'll be located in your roaming app data folder. And actually, there's actually subfolders in here. So the data is located in roaming app data on Windows. Your save data is located underneath your user folder /save games by default, depending on how the person set up Windows. And then temp is your is just your temp folder, which is located at oops, that's the wrong one. If I can spell today. Yeah, I know. There we go. It's located underneath your local app data /temp. So yeah, and then down after I've got the other command line going, I'll do like engine shader dir or something like that. But let me get the project going before I do that. There we go. Cool. So that's that. And if I go to build it now, go back to Visual Studio. Visual Studio seems to be unaware that there was a change, which is great. Yeah, so let's open up the solution again. And let's take a look at the properties here. And so yeah, we see underneath the debugging section, now it says content dir, content data dir data. Because the working directory is already the project solution, that is fine. So let's see here. The program won't run still at this point because I still haven't redirected the include folder, and that's what I got to do next. So back to file.cvp, there's two places I need to specify this, I suppose. Well, yeah, there's a couple of places I need to specify this. So internally in the file system, I would keep track of where the paths were using these string global string variables. With the shader, though, I guess I would need to access that location from here. So this is the part of the GLSL parser that we worked on yesterday, where we got pound include working, the include directive. So what we would need to do is we would need to get this section from the file system. And this is a very specific thing to be getting from the file system. So instead of doing like a getter or something like that for a private member, I'll just make the variable private on file, and then make the graphics system a friend of the file system. That way it'll be available everywhere, or it'll be able to access the private stuff. So heading down to the file.h header, I'll go ahead and do friend class graphics. And so the graphics system can access the private stuff now, and I'll add a static std string engine shader path. Do Pascal case though, engine shader path. And do that in the file.cpp as well. I need that declaration for the static member. I better drink some of my coffee. Sure, it's already getting raw. There we go. Ran out of creamer, so it's just black coffee today. But I'm all right with that. All right. Cool. And now we've got engine shader path as a member variable. We just need to set it, and that needs to be set in 2 places. The first place is going to be in the init for the file system. So when the file system is initialized, we go through the steps of setting this stuff up. We need to get the command line argument for the engine. Now I have this API set up for creating new command line arguments, which works, pretty well. Basically, during init somewhere, you're going to say register command line option, and say content, or give a description of what the command does, list all of the different commands that can trigger it, and then specify a help description. So if somebody goes, dash help or whatever on the executable, they'll see this description, and then how many parameters you're expecting. So in this case, engine shader directory, the human readable stuff. For this one, I guess for the, I'm in the habit of doing the single dash one letter for the short version of the command, and then double dash with the more full description. So I guess I'll do E, because it's not taken. So we got C for content, D for data, E for engine. Though that seems a little, yeah, that's probably fine. And then we'll do engine shader dir. A little bit wordy, but this is something that I'm no longer expecting the dev to set this up themselves. And then a full description. Basically, set a custom location for the games engine shader directory. And we're going to be passing it a single argument. And I got to escape these quotes. And that's that. Now we've got a command line option for setting up the engine shader directory. Maybe I should put that as plural, because the name of the folder is engine shaders, just like the name of the folder of content is content. Yeah. And now down here we have to check it. So we've already got a check for the content directory. Basically, we just use application get command line option, and we check. We get a vector containing all of the string arguments that followed it. We're only expecting the one. So we got to do the same thing down below. Might as well just copy the whole structure. And now we're doing engine shaders directory. And now instead of doing looking for content dir, we're looking for engine shaders dir. And we can just reuse command line path, that variable. It's a vector for SSD strings. We can just reuse that from the previous command line options. So the first thing we're doing is we're checking whether there were any command line options. If there weren't any, which means that either they specified engine shaders dir without the expected argument, in which case they'll get a command line warning, or they just didn't specify engine shaders dir. Then we'll set that up with the default, and that's handled on a per platform basis. Even for this, because on Mac OS, the location of the engine shaders directory is actually going to be located in the app bundle itself. So it's not as simple as just doing /engine shaders for the relative path. I actually have to specify the member of the app bundle when I do it on Mac OS. So for here, we will leave that for a second. Actually, let me give it a new name. Set platform e-shaders path for engine shaders, and I'll define that in a little bit. And then I have a helper function that takes and converts backslashes to forward slashes from the argument. You can use either direction. People who are working on Windows might be used to doing backslashes in their arguments, so if they do, then we'll just convert it to forward slashes and we'll be able to parse correctly after that. All right, and then from here, we are setting the content dir path to the results of that conversion, and that's actually not correct. That needs to be the new engine shader path. And that'll take whatever the path was provided to that command line argument. It'll append a slash if there's not already one on there. And then when I go to use the virtual file system to write there, it will use it'll use the contents of this string to prepend whatever path I specify. So yeah, I should probably rename that actually to be shaders path, so just so that I'm consistent everywhere. Yep. All right. Good. Cool. And then I'll need to implement this now. So there's a platform-specific version of file.cpp. The way that I've been structuring, I forgot I have to turn this back on. When you first make a project solution, Visual Studio defaults to using the filters instead of showing the actual folders, and I don't like that. I like to actually see where things are on the system, so I always turn this guy back on, show all files. But the way that I've been structuring stuff like platform-specific code is that whenever a system needs platform-specific stuff, I'll have a little directory containing a platform-specific version of that file. So in this case, for the file system, all platform-specific stuff that would otherwise go in file.cpp go into file_win32.cpp. So this is where I would implement the set eShaders path, or set platform eShaders path. Here. And this has to be a member function because it's going to be accessing the member variable. So we'll go back to this. We'll do static void set platform eShaders path. And then back here, I'm just going to go ahead and copy out the code from the create content path, because it's just to give myself a bearing, a point of reference. We're doing the engine shaders path now. And instead of going to content slash, this is going to go to engine shaders slash for that location. And then we'll do sd error code ec. We will use create directories to create that path from the virtual file system. This is just to make sure that any commands that we might run to that location, if for whatever reason, like it's a fresh project, and that location doesn't exist, it will create that path first. So I'll go ahead and update the error message if that fails. File set platform eShaders path unable to create engine shaders data path. Cool. I think that's it for the redirection stuff. So platform eShaders path, command line argument, engine shaders dir. Kind of a wordy argument, but I think I'm okay with it. All right, and then we go back to where we were in shaders. So in shaders, we previously were just hard coding, go to engine shaders slash whatever. But now this will be replaced by whatever we specify in the command line argument. So let's do that. It's going to be file engine shaders path. It's a private member, but remember we made the graphics system a friend of the file system, so we can access that directly, which is helpful because I don't want developers to go file engine shaders path and see it in their IntelliSense or whatever. And yeah, I think that's all there is. That's the only location I needed. Yeah, it's literally the only place that I used the hard-coded path before. So now that we have specified all that, let me go ahead and compile the thing. But while it's building, I will need to get the argument working. So here's where we were specifying the arguments. Got content dir, content, data dir, data. And for engine shaders dir, yeah, we need to specify a path now. Now this path is a little harder to derive. We are starting in here, and we're going up a level. We're going into enterprise, and then we were going into engine shaders. So the good news about that path is that I don't actually need to know any data about, like I don't need to know the name of sandbox or anything like that, so I don't need to do any like Lua string concatenation. Instead, I can just go up a level, and then into enterprise, and then into engine shaders. Yes, like that. And because of the robust way we check for the slash when we read the argument in, it actually doesn't matter whether I use the slash. I will go ahead and use one. No, I won't. I'll just do like that, and it should be fine. So now we've got the debug arguments redirecting the content folder by default, the data directory by default, and the engine shaders directory by default. Cool. So is the build done in? Yeah. So the build's done in Visual Studio. It still shouldn't be running correctly. Oh, that's weird. I thought it had built. Did I hit the wrong quick key? Oh, Control B. I built Enterprise because that's the project I was in. All right, whatever. This still shouldn't run correctly because we're not redirecting the thing yet. To do that, I'm going to go back to the terminal at the bottom of Visual Studio Code here and run the premix script. It's regenerated the vcxproj.user. So we hop back in here. Wow, Visual Studio is not waking up to changes to the project file anymore. Let me reopen the solution, and then check out its debugging section. Yeah, so now we've got content dir content, content data dir data, engine shaders dir enterprise / engine shaders. So that should be all we need. Just run it. All right, it's working. Cool. So this is, yeah. So this shader here was assembled using the header located in enterprise engine shaders. So the contents of this file, enterprise.glsl, this was basically copied and replaced with this to produce the full shader file, which is exactly what we want. So I got Madeline spinning here, and this shader is just a very simple shader. Literally, all it does is it takes puts the vertex in world space, or in view space, and does a texture sample to get the color. But yeah, now I no longer have to do that boilerplate code. However, there were some leftover bugs from that I had noticed from the last stream that I need to address. I got a couple of them pulled up here. So we've kind of figured out the working directory conundrum, but there's still the aspect of getting this to work on Mac, because as I mentioned, I can't just use premix debug args to set up the command line stuff for Mac OS. If I was to do that, it would just ignore it. So I have to actually go in and manually generate myself a Xcode scheme file, and that's simpler than it sounds, it turns out, but I still got to put the work in, so I'm going to leave that on my Trello board. The next thing was, well, there's a handful of things. I'm going to do them in the order that's easiest. There's an infinite parsing loop when the shader file has just one new line at the end. And I don't know how on earth this what happened. It turns out that this was a problem before yesterday. Like it wasn't something introduced by the GLSL stuff. But if I was to do this and hit save and then run, run. Apparently there's a problem in the parser where it just gets stuck in an infinite loop. So I need to figure out what that is about. So I guess we may as well just get started. All I did was just pause on the debugger to see that we're in the loop. So for starters, it says line number is, wow, what is that? 21. million. Yeah, so it's apparently getting to the end of the file and then just like continuing. So let's, inside this for loop, let's take a look at the end of the file. I know that it's getting through all of the different phases of parsing. It's getting to at least phase 4 here because the shader works if I if I have multiple new lines at the end. So what I'll do is I will skip to this section, parse from there. All right, so now we are looking at nothing. Line doesn't contain anything. So in the inspection here, line is a STD string view looking into the source. And it's supposed to be just my window into the source without having to actually allocate a string. STD string view is really handy for parsing, in my opinion. You can do all kinds of it. It makes your parsing code a lot easier to think about while avoiding having to reallocate everything. So I really dig it. But it seems to be pointing towards garbage right now. Actually, it's empty. It's zero length vector. So what I'm looking for right now is the next shader section. So after you get through, when you're parsing through the GLSL, after you reach shader fragment or shader vertex or whatever, from then on you're just writing out shader code until you come across another one, and then you change your mode and you write it to that shader's source. So we're doing that until we reach the end of the file. So in this case, the line was empty. We went to find either the first / or the first £. We care about the / because we actually do have to be aware of entering a multi-line comment in case the next line has got something that we think should be commented. So it skipped out because we went searching for the first thing that's not a / or a £, and there wasn't anything. So that's expected. We then go cars to next line start plus equals line.length plus 1. So we move cars to line start. Oh, that's interesting. So the line number currently is at 21 million, meaning that it's read through 21 million lines, even though this is just a 30-line file. So we know that that's going way past the end in the loop. But cars to line start is at 68. Which is actually way less than I thought it would be. Because if it's looping infinitely as well, then you'd think that it would be up in the millions along with So I guess we're going to need to come at this from a different direction. Let me put a breakpoint in at the bottom to begin with, and then we will track what happens as we approach the breaking point. Here we go. So this is this stuff is introspection. We do introspection on the program to handle linking and binding things later, but and that's the assembly and compilation step. All right, so yeah, we're back to where we were. So first thing I'll do is I will just put breakpoint there and throw in the debugger. And all right, so the first line that we reach the step on has nothing in it. That would be this line on line 10. And if we go to line number 10. So I continue. Now we're on line 11. Oh, I'm gonna have to do this for every line after line 10. So let's speed that up a bit. I'm going to put a condition on the breakpoint to only break on line 29. Conditions line number equals 29. Close. And then continue. And now we're on line 29, which 29 is this last command, final color equals texture text UV. And I'll just step through what happens after that. So cool, it breaks out because the line doesn't contain the pound shader directive. The following line doesn't either because it's a closing bracket. And then the last line, this is line 31, so we're now on the final line, probably where things go wrong. Okay, so we're searching on the last line for slash or pound. We know that there isn't one. Oh, okay. We are not getting STD NPOS though. So the way that I check that there's nothing else on the line is I compare it against NPOS. So actually we're not getting NPOS. Cursor is equal to 0. And I'm willing to bet that that's because find first of will return NPOS if it encounters a new line character, and there's no new line character on this line. Let me take a look at the docs on this. So underneath string view, if we go to find first of, finds the first character equal to any of the characters in the given character sequence. The one that we're using is version 2, which is equivalent to find first of basic string view address of C1 position. Okay, so that's actually just like, yeah. Return the position of the first occurrence of any character in the string, or NPOS if no such character is found. That's interesting. Just going by the wording of the docs, that kind of suggests that we should be getting NPOS, because it's not a slash, it's not a pound, it is an end of file, or a nothing actually. Oh, okay, hang on. Line number 31. Oh, there's a problem with how we're getting the next line. I'm taking a look now. It says line number is 31, so we should be on the empty line. But the line substring variable is now actually pointing towards the first line of the file, where it says / basic shader. So that is pulling up. How did that happen? Let's take a look at that start of that for loop. So I'm not actually like using like an IF stream or something here. Instead, what I do is I load the entire shader file into memory, and then I just read through it as a single block of bytes, and I identify all the places where I want to copy and paste chunks to assemble the final shader file, and I just pass those values to GL shader source to have GLSL or have OpenGL assemble the shaders. But yeah, apparently when I go to get the next line, so line equals std string view from source.data plus cars to line start. And the length is source.find first of /n/o. So the new line or the new termination character, or the line termination character. So let me review that constructor real quick. So we're getting a character pointer. We are getting the number of characters we want. Cars to line start somehow got set to 0. Oh no, it should have been. It should be 0. So we got the. No, it shouldn't be. The cars to line start should be the entire length of the file at this point. Okay. So somehow that's getting set back to 0. And the only place that I set it, I believe, is at the start. In the for loop itself. The purpose of cars to line start is to allow us to take and directly find a position in the buffer that represents the start of a line. So cars T is a size type, so it's 64-bit value. It should never really overflow ever in my working cases. But the only time I modify it is here and here, where we plus equals line.length plus 1. And so I guess there's a danger there that cars to line start would be moving past the length of the source. But if it does, then it will become greater than or equal to source.length, and it will break the loop. That's the idea anyway. Let me go back a previous iteration of this parsing step. I'll put the breakpoint here again, and I'll set this to conditions. Line number equals 30. That's apparently where things go wrong. And we will stop. We will start over. All right, now here we are at line number 30. Line presently points to here, where we got just the closing bracket. And interestingly, we've got oh, okay, line size is wrong. Looking at, I'm inspecting the size variable. The pointer is correct. It's pointing towards the closing bracket, but the size is npos, or the maximum possible value for size type. So how did that happen? The problem with this is that if we do line.findFirstOf, well, it still won't find anything because it'll reach a null termination character, but that's I don't know if we can count on that being there. Or I guess we can, because the way that the source code is loaded, it'll guarantee at least one null termination character. But let's follow this through. We have presently cars to line start is 380. Which kind of adds up. It's in the ballpark, but there must be something being parsed out that I'm forgetting about. Let's take a look at the buffer itself. When I take a look at the file, when I go to select the characters, I'm getting 380. Oh, it's because I'm using CRLF. Let me go to LF. We'll do 300. Yeah, 380 characters. So that's actually correct. The by default on Windows text files, the line will end with if we go to open up a file in a hex editor, the line will terminate with two different characters, OD and OA, and that's the carriage return line feed. On Mac and almost every other operating system, it'll just be line feed, which is the new line character OA. So when you use C and C++ API stuff to read text files, it'll strip out that OD. So the character count was off compared to the thing we're working on. Yeah. So cars to line start is correct. I suspect it's going to be less correct after this loop, because what it'll do is it'll take and add the length of the line, and that's currently npos. Okay, now we're in the outer loop. Cars to line start plus equals line dot length, and line dot length is the stupid long number. So now cars to line start is hit 0 plus equals. Is this not actually npos? Pretty sure it's npos. Valid input, it says. 4467 row 737 0955 1 2 3 4 3 2 1. Okay. So it may not be exactly npos. Let me take and test the expression using the watch window. I'll take line.length plus 1. It doesn't wrap around to 0, because if it did, then it would actually display a 0 in the console here. So like SDE string npos plus 1. So it's some value south of npos. But the value somehow wraps around to exactly 0. This is nuts. So it's line.length plus 1 plus, well, let me break again. Cars to line start. I have a suspicion that the line.length is actually npos minus the cursor. Yeah, so line.length plus cars to line start equals npos, because you add 1 and it goes wraps around back to 0. So we're having a integer overflow on a 64-bit value because the length is calculated wrong. So that's apparently not a problem when there's an extra line in between. So let's head back up to the for loop, because that's probably where this is being set. So line is set by constructing a pointer plus cars to line start. Which at the start of the end line, build save, at the start of the end line is correct. It read to be 380. And then we search for either a new line or a null termination character. Starting from cars to line start. Oh, but if it never finds it. Oh, that's how. Okay, that's the problem. So what we're doing to find the end of the line is we're searching for the new line termination character or the null termination character for the end of file. But if it finds neither, then it will return end position. And then end position minus cars to line start becomes the length of the line substring. And when it gets re-added here, line.length plus cars to line start plus 1, it exactly equals 0, starting the loop over again. Okay. So we need to wrap this. We need to or modify the search. So first of all, why is that not working? If we're on line 30, let me try this again. So presently we are on line number 30. Yeah. So we're on line 30. The line is still getting the wrong length. It's searching for end position or the new line termination or the null termination character on line 30, and is returning end pause. That for sure can't be right, right? Because there's a new line here. I'm going to quickly analyze this in CRLF, or sorry, LF and line ending mode. So there's the brace. There's the new line character. So if we reopen this back in text, and I change the line ending back to CRLF, and inspect it, so either way, we've got the null termination character. Open editor with text editor, or text editor. So there must be something wrong with the buffer. Maybe I've read it into the file wrong. Let's take a look at that. So the size of the source buffer is 381 characters. The 380th character is the closing bracket, and it doesn't list anything after that. The buffer is missing a line. And so when we go to search for the null termination character, it is, or the new line, it is actually missing from the contents of the string. Okay, all right. That tells me that there's a problem with how the string is loaded in the first place, which means there's something wrong with my root text function. File.cpp, or no, it's file.file132, which I have over here. There's a method, load text file, which is invoked. And this method simply calls fread on the file, or fopen to open up the file, fseeks to the end, gets the size of the entire file in bytes, produces a string that's the length of that, and then copies it. So there must be something wrong with this, because I'm missing characters from the end of the buffer. All right, so let's review how this works. Cool, I think we're just about at the bottom of this. So first thing it does is it converts the path to the native path, which is, tried and true at this point. We call fopens on the file. We fseek to the end. We take the output string and we say resize to be the number of bytes that we read. And on technically this could be longer, right, than we need. Because if we're dealing with a CRLF ending and we do an fseek to the end, it'll give us the number of bytes including the carriage return. But then when we use fread instead of fseek, fread actually will read in text mode, and that handles the stripping out of the carriage return characters. So that way it's platform generic, the platform generic string that you get. So at this point we've read in the bytes using outstring dot size as the maximum. And then I resize to outstring find last not of the end of file or the null termination character. The null termination character is not used until the end of the file, I thought. But it sounds like that's being detected early. So let's put a breakpoint on there. And this is going to go through a couple of different files. Oh, actually, no. The very first file loaded with load text file is the shader that I'm looking at. So good. So let's take a look at the outstring. Outstring, this is the stuff that's been read into the string. We have everything, including the new line character here at the end. And if we step over after the resize and I inspect it, we are missing the new line termination character. So I don't really understand, because it should be detecting that new line character, right? Let's take a look at the before and after again. So in the before, can I open this up in I'm going to have to manually open up a memory window. I thought there was like a right-click option that lets you just inspect that address. But I guess I'll have to do it from here. We'll do out string 0. Oh, come on. I know that you know where that is. For real? Oh, out string is a... Yeah. No? What? Oh, come on. Let me just copy the address then. Here. Is that the wrong address? Okay, yeah, I guess it is. That's weird. I'm searching the address that pops up here, but that must not be the address. That must be something else. Because when I look it up in memory, I'm getting this garbage that's not actually the string. Oh my God. Well, let me just look it up in the watch window. Okay, there's the address. Let me get it. Get me the address, please. Copy value memory. Okay. There we go, finally. Let me open this up in the big window. So right now I'm inspecting the actual memory address of the string. And I'm taking a look at what actually follows what actually follows the last character. So this is the entire string. Come on, show me this character on the left. I guess I'll just copy this all out and throw it in Visual Studio Code. What I want to do is I want to directly compare the character on the left, and I don't like the idea of having to interpret all of this text. So let me just copy out this whole thing. So this is all the null termination characters. Well, actually, now I'm already reading it. So let's take a look. 7B, I believe, is this. And then we have 0A, which is the return, and then we got all these null characters. Wait. Okay, now let's go back to VS Code real quick. Open up a new text file. Open editor with the hex editor, and oh, can I not just type it in? Fuck me. Whatever. Let me do just one containing that, and I'll say reopen editor with the hex editor. 7D. So 7D is the closing brace. It should be followed by a new line, and then we've got zeros, null termination character. And starting all the way from the start of the file, I shouldn't see the null termination character anywhere else. Kind of hard to read through all this, but I'm not spotting any zeros. So somehow or other, we are getting to this point, and the OA is getting stripped. Oh, I'm such an idiot. Okay, I think I know what's going on. So find last not of should be finding the position of the character before the termination character. I have been setting the length of the string to that character's number, but the length is always +1 on that, and I have been cutting off the last character. So I have not been getting the null termination character, but more importantly, I have not been getting the end of file. So when I go to search for that last line, unless I have a buffer line in between, it will think that it'll think that there's no end of file character, basically, or no null termination character, which is, yeah, that's why it gets stuck in that loop. That's okay. That's kind of a weird perfect storm to get the result of this problem to come out in the way that it did, because it's not giving me any warnings. It's just giving me it's just looping back through the loop, giving me an infinite loop, because of the integer overflow just happens to exactly equal 0 when we check that condition, or when we actually use that value. So great. Okay, so that's that. So that sounds like the end of my problem. Let's try this again. Yeah, and stop at the breakpoint. Yes, okay. All right, that was a pretty awful bug to find, but we fixed it. Yay. Jeez. There we go. And archive. Perfect. All right. Now we need to take a look at a few of these other issues. If and when the file doesn't load correctly, so if I say include with the angle braces, if it looks for enterprise.glsl and can't find it, technically that's going to be a problem on its own. But what I was expecting to occur would be that it would strip out the line anyway and still try to compile. I'm on the fence as to whether I want that behavior now. Just because that's what I was expecting doesn't mean that's the way it should be. So for example, if I was to replace the header from enterprise.glsl and say garbage.glsl, and then go to run the file again, we have an exception being thrown for validation, but before we, exception, EPGL, do I actually have it throwing an exception? I don't remember doing that. No, what I did is I called a debug break. So why does it say exception? Triggered. Oh, it's not. It just says exception thrown, even though it's actually just a breakpoint. Because I manually invoke a breakpoint here. Yeah. So I invoke a breakpoint, but the console tells us that include file does not exist, which is the warning that we want because we can't find engine shaders.coverage.glsl. But then the next line says Vertex Shader compilation failure. OpenGL does not include directives. And then it shows us the contents of the file. These warnings are actually okay, but the question is, do I want it to leave the include in there and just automatically fail to compile? Or do I want to strip it out and attempt to compile without the include line? On the one hand, if you have the include directive pointing to the wrong thing, you're probably going to have issues anyway. But it's not necessarily true that that would prevent your program from running or being able to test out most variants of your shader. Because if I use pragma option to make multiple variants of the shader, the variant that doesn't use the stuff in the include, if there's any variants that don't use the contents of the include file, might be fine. So perhaps what we want to do is we want to strip out the header. And so when it fails to load, we get the warning saying, include file, whatever does not exist. We are looking for it in test shader line 5, which, that's points you to the exact line of the source code. But if we want, we could then still strip that out and then send the rest of it to OpenGL and see if it can compile. I think that's what I want to try. I think now that I'm thinking through it, that yes, that's actually I do want to have that behavior, um, because you never know. If you're making a system with a very specific use case of a header, then you want to be no problem if it doesn't load correctly. Like maybe you've made like a header that contains helper functions that you're not using anymore, and then you delete the unused header from your source control, and you forget that you referenced it in a GLSL file somewhere. Like you don't want that to trigger a crash. Actually, you would want it to. Well, you would get a warning. Yeah, so it wouldn't impede your other work if you came across that warning. So let's go ahead and handle that. Presently, the way that we handle the include directive is that we will strip it out only if we confirm that the line is correct. Only if we confirm that it is a pound include directive. What we need to do is we need to flip that order on its head, and strip it out no matter what. So that means taking this and moving it above, and this moving it outside of the current loop. So let's do that. Well, actually, hang on a moment. So if we find a line that starts with pound include, we could just terminate the existing string here and then resume it after. Yeah, checking the nested for loops there, we are actually good on that front because there's not any code in here that would call break and then leave this block. When I'm wondering about those multi-line comments. Because if I was to skip over the parsing here, that would leave us on to the next line. without knowing whether we're inside of a multi-line comment. Yeah, you know what? Forget it. It's going to be probably too much effort for too little gain to bother to do the replacements otherwise. So I'm going to put that squarely on the back burner. We'll just go ahead and use headers the way that we already have them. And then if you screw up and you reference a header that doesn't exist, then the shader, none of the shader variants will compile. That'll just be the way that it is. Okay. Then the next thing to look at, and I guess I didn't write it. I guess I didn't write it on my Trello board. But realizing just reading through this code that I didn't address it. There's the question of whether we're using the engine shaders path or whether we're using the actual path. So the angle brackets are used specifically for loading from the engine shaders path. The quotes are for anything that's in the regular virtual file system. So in order to make all the parsing code, in order to prevent code duplication, I did the parsing with either the quotes or the angle brackets. But here's where I need to actually make a difference. So if we take a look at the parsing code, include path here is constructed always with file engine shaders path. I need that to either do engine shaders path with angle brackets or use just a regular path with quotes. Either way, this is going to be fed into file exists and file load text file, and both of these APIs accept virtual paths. So I don't need to change any of the API down here. I can literally just change this one line, change this one section. So at this point we've got if the cursor equals this or this, we'll do this fork. And I'll do if line subcursor equals the closing bracket, then I'll know that this is supposed to be the engine shader path, the engine library provided shader header files. Else, we will set include path to be just the string without the prepending. And I need to move that declaration outside. Oops. Yeah, and then down here we hash it for use in the well, actually, we're only hashing it in 2 places, but whatever, just hash it and then use it in 2 places. And I think that's that. So if we use the angle brackets, we will look in, technically what we'll be looking in is the, whatever the file system puts engine shaders / we're looking within that folder. So when debugging, it's going to be that redirected location within the enterprise project directory. And on a shipping game, this will be located within the content directory right next to the game. But if we were to put this in quotes, it would just use whatever virtual file system path you provide. So you could do C to get into the content folder, you could use D to get into the data folder. Probably always C, now that I think of it. I can't think of any good reason why you'd put a GLSL file in the user data folder. That would imply that you're generating shader files based on user input, which, I guess it's not impossible. There might be some weird niche game where like you can put GLSL or like shader programming as like a gameplay mechanic, but I mean, I really doubt it. Maybe some utility you might use that for. But now that I'm thinking about it, maybe I should just take and prepend the C automatically. So that way, when you're doing one of your own systems, you go include this, and then within the quotes, you're already within the content directory, and you just go shaders like portal rendering .glsl, and then it would automatically look in the content directory without you having to do this, which you're virtually always going to have to do. Yeah, I like that a lot. Let's do that. In the path then for the include path for in quotes. Just to make that a little bit more clear to future Michael. I would do C/+ and this will prepend the C/ on top of whatever's in the quotes, meaning that it'll always automatically look into the content path. So that should be good. To test that out, let me go into my content folder. Here. I'm going to go ahead and paste the enterprise.glsl header. Open it up in code, content, enterprise.glsl. I'm going to comment this out. So when I run test shader and put quotes around instead of angle brackets, and I run the program, I should expect a problem. Because I commented out uniform buffers that contain variables needed by the shader. Good. And if we take a look at the console, it says Vertex Shader violation failure because of an undefined variable EP matrix and MVP. We see that the shader header file worked fine, but it's commented out because it's the copy that I put in my content folder, and then because of that I can't compile because I'm using the MVP matrix down in my Vertex shader. And if we stop debugging and we go back into the shader, put it in angle brackets again, it'll work just fine because it's doing the substitution from the copy located in the EP shader folder, engine shaders folder. I might rename some of these things before I do the commit to my repository. But yeah, that's that. We've got quotes working into the content directory now. If I was to go into enterprise GLSL and uncomment out that stuff, we'll find that it works fine. So cool. Okay, that's the next most critical part of headers working. Good. There's only a couple of more things to look at. This is kind of a nice to have Though it technically makes parsing simpler and faster. It's not going to be a huge speed up we're talking about. I kind of decided, like, while I was doing testing, that I don't really like the idea of doing shader, fragment, shader, whatever. I just want to kind of do pound fragment, pound vertex, um, because it's a little bit easier to write and it's frankly a little easier to read. Basically, if I'm looking for the start of my vertex, I can just find pound vertex and that's it. So I think I want to spend a little time today and actually change this around so that I am only parsing for vertex, which will actually simplify parsing quite a bit, because there's a whole other parsing stage that I've been using, um, that I don't need, if I am not having to tokenize a separate token following pound shader. But yeah, for the moment though, we've got the big bugs fixed and we've got include files working quite brilliantly, if I don't say so myself. We've got a workflow set up so that we're loading them from the library source code up until we ship the game, in which case we'll be distributing that in the appropriate location in the install folder. Yeah, feeling pretty good. I'm gonna go ahead and go on break. I'll be back in probably like 10-15 minutes. Alrighty, I'm back. Where were we? All right. Yeah, so we had just a couple of more things to deal with. The simplifying the shader to Vertex and Fragment. And then there was an interesting question I encountered at the end of the last stream regarding the UBO name bindings. So inside of it's so great to actually be able to go to the header now. Can I do control click on? No, that would require special linting. But basically, go back to enterprise.glsl. I had noticed during my last stream that you could change the name of one of the uniform buffers, and it would still apparently bind correctly. And when you go to set the uniform data, it still sets correctly, and I wasn't expecting that. And I don't know why that happened, so I'm going to need to investigate that a little bit before I start writing a whole bunch of shaders using the system. But yeah, before I do that, it just occurred to me that I made a change to load text file on the Win32 file, and I need to do the same for the macOS version. So we go to File, macOS.mm, load text file. These differ a little bit because of the way that fopen differs between platforms. MSVC does not allow you to use the regular fread anymore. You have to use fread-s. But on Clang, it's the other way around. It doesn't have fread-s. It just does fread, the regular kind. So I actually have to branch this depending on the platform I'm on. Here we go. So on the Win32 version, load text file, we use fopens and then fread-s. On here, we just use fread and fopen. So the fix that I had to do was to take, and when I do the final resize, do a +1. There's also a bit here about CRLF. Because the platform natively already does just LF line endings for all text files, the C standard library stuff, things like fopen and fread, they don't actually handle CRLF files. They literally just will, when you operate the code in text mode, it'll just assume that the file will be LF ending. And I didn't understand that when I first was working, and so what I wound up having to do is literally go through and parse out the /r, the carriage return myself in order to produce a file that had just LF line endings if I was trying to open up a file that was created on Windows. So yeah, that's part of it. So taking a look at the resize operation. So the resize is handled a little differently here. The first thing that we do is we call resize to ftl handle. That gives us the number of bytes that is in the file. So I just make sure that the output string has enough room for the contents of the whole file. And then I use fread and push it into there. Then I go over every character in the string looking for CRLF. So it's just a once through parse, and I will shift over everything to replace the carriage return whenever I find it. If we do, so by the time I get to the end, I will be, so I is less than outstring size I++. I plus *diskette +1 is less than outstring size. we do the +1 because we need to check not just the current character, but the character beyond it. So by the time we get here, I plus cars to skip +1 is less than, or is equal to or greater than outstring dot size. Meaning that the cursor I is at the second to last character. And that's when we do the resize. And I don't do a break here because outstring dot resize will automatically resize this to the point where it'll break the loop. But trying to track my thoughts from when I wrote this originally, there might still be a problem here. Because if we get to the second to last line, or second to last character, if I plus cars to skip +1 is less than string size, this would mean that either we are on the last character, or we don't, or it couldn't possibly be followed by an N. So it couldn't be a CRLF, it could only be a CR. This needs to be +1. However, I am not 100% sure about this code, so instead of dealing with this now, I'm going to make a note for myself to do it later. And I'll go ahead and just do it as a comment. And then I will test this out on Mac when I go to build it next. It's maybe a bad idea to edit code without being able to test it before committing. So because this isn't literally the same thing as I do in file 132, I'm just going to deal with it later. But my impression is that this will also result in a similar problem where it'll cut off the last character, and yeah, so I can test that later. Anyway, I'm done with that. And then back on track with the parser. Going back to shaders.cpp. So looking at the overall structure of the parser again. Here we go. Yeah, there's a lot of stuff that it's checking for. This basically operates in a series of modes, parsing states. One of these parsing states is literally just dedicated to finding the term following shader. So that's parse state 3. So basically, after we have found a pound shader, this guy, inside of a shader file, we then move to the next mode where we search for just this term and handle it. the idea there is that it's supposed to be expandable, but you know, like once I get other kinds of shader, like geometry shader types, for example, going, I could just add a state in here, but that's not very helpful, in my opinion. So my goal is to make this section, this whole chunk of code, which is, what is that, 300 lines, make that obsolete and just handle specific shader cases in case 2. So to make that work, I'm going to go ahead and first set up my test condition, which is that I will take out pound shader from my test shader. So I'll know that it started to work once this reads correctly and we see Madeline spinning on those 3 mishappen cubes. All right, so in here we do searches for 3 different statements. Shader is this one. The idea is that instead of looking for shader, we will look for fragment or vertex. So I'm going to leave shader intact for the moment, and I'll just do the else if for shader or vertex. And then how many characters is vertex? 7. Comparing that with vertex. And else if line dot compare cursor, and fragment is 1 character longer, right? That's 9. 2 characters longer. 9. And we'll do the handling of that there. What's wrong with? Oh, I put a. Don't need that. Yeah, that needs to be equal to 0. Okay. I should take a look at the plus 10 requirement. Because basically I am asserting that we have 10 characters left over, because for all the cases that I had been handling before, in order for the statement to be valid in the first place, I would need to have a space plus at least a couple of characters. The only pragma I support is option, so option automatically has at least 2 characters. Shader would always have at least 2 characters. In the case of vertex and fragment, though, they might not have 10 characters. So I might be looking at a code duplication situation here. Fragment requires at least 9 characters, but if it's literally the only thing on the line, it'll fail this check. So I don't want that. I need to have like this here, and I need to have it in this else block, like that. Or, yeah. Oh, that just needs to be a regular if. So I'm not necessarily a fan of that. Let's look at how complicated the result will be if we encounter it. So it's actually not all that complicated. We continue to parse for multi-line comments. Which actually this version of searching for multi-line comments, the code that I wrote here, looks like it might be a little inefficient. Let me take a look at the code I wrote yesterday for multi-line comments and the include. Yeah, this was actually way simpler, so I'm not going to copy over that code. But basically, I just parse for multi-line comments and then set a couple of pointers. Down here. So what we do is we basically just terminate the vertex shader source string because up until this point we are parsing for both shaders, and then we open up the current one. That's not right. Hang on. I'm getting this confused in my head. Oh, I realized where I'm missing the step. So what this does is if we encountered the if we determined that we had a pound shader vertex, then at this point we are starting a new string on the vertex shader, but we must have already terminated it after finding the shader line. And we're going to need to copy some code out of here. Yeah, so when we find shader followed by white space character, and this is in the global section, then we terminate both the fragment and vertex shader, so that way each of their own copies of the global section, the section before the first pound vertex or whatever, those stop being written, and then following that we start writing Yeah. So actually what I need to do is I need to do an else if vertex or fragment up here. And then I need to update the case 4, the state down here where we're parsing out sections. And instead of doing shader and switching to mode 3, I parse for fragment or whatever. So that's actually looking to be quite a project. Okay, but I think I'm kind of getting the structure of the problem in my head. So there's going to be a little bit of code duplication, but I guess that's unavoidable. So let's copy out this stuff. If we are in the global section and we find vertex or fragment, we will need to terminate the string on the other. So that'll be here. Oh, that'll be here. Interestingly, I tried to use KF to do the tabs correctly, but Visual Studio stopped tabbing them correctly, so I'm wondering what that's about. But basically, if we encounter vertex, then we want to terminate the string for the fragment shader, and vice versa. If we encounter the fragment shader, we need to terminate for the vertex shader. We can just kind of leave the ball or the ticket, the tab running for the other, or can we? Hang on a moment. No, we can't, because in either case we need to omit the pound vertex or pound fragment line. So actually I need both of these in both cases. And then following that, I need to start the new line on the others. So let's make sure that the cursors are correct. So cursor to line start plus cursor, which is pointing at the pound sign still. So cursor is at pound. Minus OGL vertex shader source strings dot back minus source data. Yeah, that's actually correct. All right. So after we've got the global section strings terminated for both shaders, we need to start the string from the next line. So we need to parse the rest of the line for multi-line comments, discard the rest, and on the very next line we will start up. So, boy, this is kind of hard to keep all straight in your head. In multi-line subcursor. So in the section where we, that's the include, in the section where we are looking for the next state. So at this point we, when we're in the shader parsing, or the pound shader parsing, what we do is we push the cursor 8 characters in, we move to the next parse state, and then we handle the rest in parse state 3. So let's review parse state 3. Okay. In parse state 3, we search for the first thing that's not white space, and we check whether it's vertex or fragment. We don't need to do that check anymore. We already know whether it's vertex or fragment. But then we move the cursor past it, and then perform the multi-line check. So while cursor is not equal to the end of the line, we will do the search. If we are in a multi-line comment, we search for the star. If we find one before the end of the line, we move the cursor past it and do the check again for the termination of it. This check is actually redundant because we're going to be looping back to the next line. But in multi-line comment, line dot find first node of white space. If we find a slash, we will check the next character for another slash for the end of line comment, and if it is, then we move on, which that could be handled by a break. If we find a multi-line comment, then we change to that. We move the cursor past the slash, past the star, and then move on. Okay, so in principle, this code works. But I'm going to want to clean that up actually. Okay, so we'll do it first for the Pertex Shader. So at this point, we know that we've made it to past vertex, so we're going to say plus equals 7, because currently it's pointing towards the pound sign. We want to do 1, 2, 3, 4, 5, 6, 7. So it's pointing to the character after vertex. Then we do a while loop, checking for the multi-line. I'm going to do this as a for loop to indicate that it's not indefinite. I can put the increment in the initial statement. And then, in this case, I don't actually want to increment the parse because the way that I move to the next character depends on whether we're in a multi-line comment. So if we're not in a multi-line comment, we find the first thing that's not white space. If we find something if we don't find anything that's not white space, then we let the loop break on its own. But if we find something that's not white space, we check whether it's a slash. If it's not, then we want to emit a warning that there's some garbage on the line. We'll do graphics compile source unexpected token after pound fragment. Are we on fragment or are we on vertex? Vertex, after the vertex statement. Token has been ignored. Program line, and we got the program line number. All right, good. Then after that, we search for space, a tab, a return character, so all white spaces, or a slash for the next comment. If we find a slash after pound fragment, we move the cursor past it. We check the check that that position is still within the string. If it's not, then we found a slash that was part of an invalid token. So we pass the same warning. Otherwise, we will check the following character to be either a slash or a star. So if it's a slash, we go ahead and move on because that's the end of line comment. To make this a little bit more explicit, I'm going to use the term break. What I was doing in the previous version when I wrote this parser was I was setting the failure condition for the loop, and it would break the loop that way. But I mean, I don't know what I was thinking, to be honest. You should use break to make it clear that that's why you're making that change. And then if we find that this is the sort of multi-line comment, we mark it as such. We move the cursor past the star. But that's actually not enough. I need to perform a search for the next thing after, for the next loop to investigate. So that cursor, instead of cursor plus plus, we'll need to do cursor equals line dot find first of. We're looking for the closing star, and we're doing it from cursor plus 1. So that way when we start the next loop, either we're pointing at the end pause or we're pointing at the star that will terminate the multi-line. And then if it's anything else, then we're looking at garbage. Yeah, we output a warning. And we find the first non-white space character or a slash. Is that what we want actually? If we find garbage, yeah, if we find garbage after the slash, then we still need to search for the multi-line comment. So we continue. It's possible that this code would generate a bunch of warnings for just one line of garbage, but I don't really care about that. As long as the dev knows that there's garbage, they can take care of it. So at this point we loop back and we're not in a multi-line comment, and we would start here. Actually, as it happens, I don't think I need this line anymore. We'll start by commenting it out, but I will actually take it and place it up here as the initial, because I think now in my for loop, every single branch I am searching for the next character at the end of it. So I don't actually need to perform that search every time. It'll always be redundant. So when we first get in, we're not in a multi-line comment. We do cursor equals line first not of white space, searching for the first thing after pound fragment or pound vertex. And then from there, we'll say if we're not in a multi-line comment, we just see what that first non-white space character is. And we don't actually need this check anymore either, because the loop will automatically check cursor is not equal to std string view and pause. So let me get rid of that extra check. Cool. If line cursor equals / cursor plus plus, if line dot length is greater than cursor, we just break the loop. And after we leave this section, cursor will be set back to 0 when we get the next line. I'm pretty sure. I'm almost sure. Let me think that through real quick. So cursor equals line dot find first not of space cursor plus 7. So we're starting at the thing after pound fragment or vertex. Okay, actually, yeah. I called break here instead of setting cursor to end pause, but I'm realizing now that I do actually need to set it to end pause, because that's needed for me to move on to the next line in the second outermost for loop. So I actually need to set that back again. But adding the line break will prevent me from being confused in the future. That this is not just to break this loop, it's to break the loop outside of it. So yeah, that needs to be that way. Cool. Awesome. Else if start a multi-line comment, find first of star, else star was part of an invalid token, find the first not of, yeah, and we do this again. Okay. Else, I don't need to do cursor.find anymore because it's already searched. We already searched for the star up here. We don't need to do that search anymore. And we don't need to do that anymore. Okay, so at this point we've either found the star or end position. If it's end position, then we don't even reach this branch because we have the condition that cursor is not equal to string view end position. So actually, yeah, this will move us past the star. We check to see whether there's anything after the star in the line, and then we check to see whether it's a slash. If it is, we do a multi-line comment terminated. And instead of doing cursor plus plus, the new strategy is to do cursor equals line dot find first not of a space, a tab, or a CR character, starting at cursor +1. Because cursor +1, actually I can simplify this a little bit by doing cursor +1, and then cursor +2. I don't know if that's faster, so I'll just do it this way. Cursor pointing at, yeah. So the first thing that's not white space, we are searching for that. All right. And then on the next line, we will be continuing. And we don't need to do error checking for if it's not a slash following the star, because if it's not a slash following the star, then we're still part of the multi-line comment anyway, and it's not subject to the compiler. All right. Getting closer and closer. Yeah, so that's that. Actually, that should be the whole thing. Cursor will always equal end position at the end of this, and we will be in multi-line comment will be set to the correct value at the end of it. So when we get to the next line, we will be A-OK. So now this code is good. We need to start the string reading on the next line. So let's go to how we handle this in parsing mode 3. So in parsing mode 3, after we have found shader vertex and we've checked the rest of the line for multi-line comments, we then call this code where we switch to parsing for the vertex shader. So that's we place back the pointer to the character after this line, and we set the pointer to the output writer to be equal to the address of the vertex shader source outs, which is how we generically will write to the correct buffer later on, and we set parse state equals to 4. And parse state 4 is going to continue to be a thing, so I'm gonna literally just copy and paste this code out. I think that doesn't even need modification. Man, this is complicated stuff. Continue parsing for multi-line comments. So after we've done the multi-line comments, we will then switch to parsing for Vertex Shader. Cars to line. So we've already made it to the end of the line, and we need to get past the new line character. So cars plus line to length plus, yeah. Okay, good. And parse state 4. So that is everything that we need for the for Vertex Shader. We now no longer need parsing mode 3 for it. So what we'll do is we will copy and paste this code into this guy. and then we can modify it for the fragment shader stuff. So we need to terminate both strings again, because this is the global section. We are doing cursor plus 9 instead of 7 because we got 9 characters in the pound fragment. 1, 2, 3, 4, 5, 6, 7, 8, 9. The rest of this code is actually correct still, but the warnings say vertex when it should say fragment. And then we're changing to parsing for the fragment shader now. So instead of inserting the start into Vertex shader source strings, we do Fragment shader source strings. Current shader source strings and lengths is now the fragment versions of those buffers. Parse state is 4 again. Okay. Now we need to consider the precondition of this section. So this was originally slated to ensure that we had all the characters in the string that we needed to have a valid include pragma or shader line, so that we could perform a compare and be guaranteed to have all the characters in it. I'm wondering right now whether I need that check. Maybe I just didn't think of it. If I go to compare for string view, compares two views. Return value negative if this view is less than 0, positive if it's greater than. So the length comes into that assessment. But I'm passing it a number for the comparison. So position 1, so cursor would be the position that we're looking at. Then count. Number of characters in this view to compare. What I'm worried about is that there will be some kind of exception if we compare too many characters, like if we compare do a line like this, but there's actually not 7 characters to compare. That's the only thing I really care about. So the version of this that we are using is version 5. We've got the position, we've got the count, the number of characters to compare, and we've got a const char pointer. Equivalent to substring pos1, count1, dot compare. Okay, that actually looks fine. So substring, produces an std string, and when we do its basic compare function, providing, or it's a string view actually. So it'd be the one string view compared against the other, where its sizes are implied. Then it would use this one. So I guess the remaining question is, if I pass substring with the wrong account. Oh, okay. Yeah, now I'm seeing the problem. So because substring is literally just the line that we're working in is literally just a substring of the buffer before, I'm manually finding the ends of the lines by searching for the new line character. I'm thinking that the problem arises that if I provide too many numbers for the substring, it'll actually get characters beyond the end of the line, which is not good for comparisons. Returns a view of substring where our count is the smaller count, and size is size minus pos. Is the smaller of count and size minus position. Okay, good. So if you pass a count that would make the string go longer, then it would actually take and use only the characters within the substring. So yeah, actually that is great, because that means that this check is actually redundant. Because when I do line.compare, it is equivalent to making a substring where I call starting for a position going 9 characters in. And so if line actually doesn't have that many characters in it, it'll just shorten it. Then that comparison will not be equal to the substring. So I can actually get rid of this check altogether. Where is this else statement? Else if else if. Yeah, that whole block can go. Cool. Originally, I wasn't even using substrings, I don't think. I think it was like part way through writing this parser, I realized that, hang on, I'm doing a whole bunch of string allocations by calling substring all over the place. So I switched to using string views. And now it's all much better. All right, so if it starts with a pound symbol, then we check for each of these. Cool, and then that means that I don't have to duplicate this code for the condition that it's outside of the other. So now I've got 2 working sections. I mean, working with the asterisk, I haven't tested it yet. But I've got code here that should catch and handle when I encounter a shader in Vertex. The remaining thing to look at then would be catching these things in parsing mode 4. So after we've already left the global section, we need to look for the next vertex or fragment. And we're not looking for include or EP shader anymore, or prod by option. So that's actually handled in its own parsing mode. down here. So in here we got a search for either the first slash or the first pound, because we care about multi-line comments, which is why that multi-line comments are really just like the bane of this parser. That's like the main reason why it has so many characters in it, is because I need to rule out the possibility that one of the directives I want to look for is commented out, so that people can literally, you know, do this in their shaders and it'll be fine, or do this and it'll be fine. So find first of slash pound. If it didn't find anything, then nothing happens, we just continue. But if it did find something, then we go to check whether it's a slashes, yeah. If we find a pound sign, then this is where we normally handle the shader stuff. So instead of looking for the shader, we're going to do if line.compare cursor 7, I think it's still 7, and we'll look for pound pound vertex. And we'll do the same thing for pound fragment. And we do this. Oh, I forgot a closing parentheses. We do this. Is that right? 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. We do this check here instead of the check for shaders. And then simply, instead of moving back to the parse state 3 to handle whether we're using vertex or fragment, we just directly here do the switch to vertex or fragment mode. And we are doing a check for both vertex and fragment no matter which mode we're in. That's okay. So like if somebody was to do this, then that would technically be legal. Just everything in between the first everything in between vertex and the next pound whatever would be fine. It's not worth complicating the shader to remove that check, or the parser to remove that check. So at this point, we don't actually need to do any other checks. We can just bring in the code from above. Cursor is already pointing towards the pound, which is the initial condition that we needed for that above code to work. So yeah, I can just copy and paste in the code that we just carefully wrote and modified. With the one exception that we need to close out the mode that we're already in, which is actually easy enough to do. So let me just copy and paste this whole thing. Oh yeah, I have a nested for loop that I closed. Here, copy. And down here in mode 4, I can just replace these. And actually, this check for else if the line of cursor is a pound is unnecessary as well, because we that's implicit in this check. So we'll do else if line.compare, like so. I mean, it might be literally faster, but I don't know. I don't care at this point. Okay, and that should be else if. Oh, I just realized something. Can we go back up? Yeah, I was thinking that because I was missing the else if on the comparing the fragment down there, that maybe it was also missing the else if above, but I guess not. Oh, that's because this is the first of the two. So yeah, actually I don't need it to be else if there. That should be if, because this is going bye-bye. Oh no, it does need to be else if, because I'm not in the nested block anymore. Right, okay, cool. And then this will go bye-bye soon enough. Okay, now instead of terminating both of the shaders, we just want to terminate whatever is currently open. So instead of having to deduce which one it is, I'm just going to use things like current shader, source lengths, and that's actually a pointer to whichever buffer we're currently writing into. So we just terminate whichever one we are. So if we did a vertex directive followed by another vertex directive, then we wouldn't be closing the wrong buffer. Then we continue parsing for multi-line comments, which parsing for multi-line comments does not involve inserting anything into the buffers, so that's totally fine. Now we switch to parsing for the vertex shader. So this remains the same because we're inserting another string into the other. We are setting the addresses of shader source strings and lengths to the vertex shader again. That's good. And we're going back to parse state 4. Perfect. And then I just make that slight change to the else if fragment. Get rid of that, and then do current shader source links, arrow operator, and place back. And then in here we parse through like normal and close out fragment shader if, open up a new string on the fragment shader source and move on. Okay, I think that's it. I think that's the whole thing. So at this point we should be handling fragment and vertex correctly. I guess we'll see. And we are. Look at that. Okay, cool. Because if we take a look at the source code, the source code no longer has shader vertex, it's just vertex. It no longer has shader fragment, it's just fragment. So technically I think both will work now because I didn't remove the shader section. I'm on the fence though as to whether I want to keep both. Because now I have the option of just not removing the check for shader. But I will, because of two reasons. First, the parsing goes a little bit faster if we are not checking for pound shader, because that's another tag we don't need to check for. And we also don't have another parsing mode that with logic that has to search for the first non-white space character after that, making sure that the thing following pound shader is a valid token. We don't have to do any of that. The second thing is that as it is, there's a bifurcation of code. So if we go back to the parser, back in parse state 4, or parse state 3, parse state 3 has all of the code that we just wrote. That's slightly different for handling everything post shader. So that's over 200 lines of code that we don't need anymore. And so like if I'm going to add another shader type, like a geometry shader, for example, I don't want to modify the above code and this code and the code down here. I just want to do it in as few places as I can. So I'm going to go ahead and, well, I won't delete it quite yet. I will just comment it out. Comment out case 3. And then I'll comment out the code for shader here. Come on. This code. Okay, so this is the global section parsing. Pragma include shader. So now we're doing pragma include vertex and fragment. I do a cursor ++ here instead of going to the end of the line because it's possible for the pound sign to actually be the part of something that belongs in the shader, like if-def, things that are actually handled by the GLSL compiler. Cool. We're no longer changing to mode 3 there. And in switch case 4, I need to get rid of the else if pound shader, because we're not checking for pound shader anymore, so we're just checking for the comment. If it's not a comment, we check for pound vertex. And if it's not pound vertex, it's pound fragment. Cool. So I think that should still work. Cool. It's still working. Got the shader still compiling correctly. So it's correctly differentiating the vertex and the fragment shader. So let me confirm shader vertex, shader fragment. Those should not be working anymore. Good, they don't, because it's going to say current shader source strings. Well, it's good that it's not working, but I'm not sure that I like this error handling. So essentially what I've wound up with is just empty files. Because I have a shader file that doesn't tell me correctly, at least, which shaders to compile. So current shader source strings is currently set to null. That's the pointer to whichever one we're writing to, which tells us that we haven't gotten to the end yet. So this should probably be handled with a slightly different error. If current shader source strings doesn't point to anything, then we'll know that we haven't even got a single shader in there. I should also, I'm going to put this on the back burner because the correct check to run here would not be to just to see whether or not we have loaded a section. Is to ensure that we've loaded enough sections. So like depending on how this goes in the future, eventually we will need to do a little bit more robust checking than just whether the Vertex shader and the Fragment shader were complete. I might want to write a shader that doesn't include a Vertex shader. Or it doesn't include a Fragment shader. So for example, if I'm just doing a depth only pass and I'm rendering out like a shadow map, I literally wouldn't have anything in my Fragment shader at all. I would just allow the depth information to fill the depth buffer and not fill a color buffer. Yeah, so I'm gonna let that slide for the moment because that's a can of worms I don't really want to get into. I will need to eventually when I start doing stuff like shadow maps or shadow mapping. But for now, I'll just take this as a win that we've got the correct mode working here. The old mode doesn't do anything anymore, and I can safely delete it. It'll work fine. Cool. All right. So we're very nearly done with the big shader stuff that I care about. The include files are done with a robust solutions. We're no longer getting that weird crash if we have the extra character, or we don't have the extra character at the end of the shader file. Fragment and Vertex shader marking is way simpler now. Was there anything else on my? Yeah, I guess there was one other thing on my bucket, or on my in my bucket on my list. These things that's done, and that's the UBO binding name question. So let me go back in the parsing code, and I'm just going to delete all of the redundant code that we just eliminated. Look at all that overcomplication that taken care of. Bye-bye. Okay. I think that's it. We got the global section done. Shader section done. I guess changing the case value. So let's go search for parse state in the current document. I'm going to take anything that was going to parse state 4. Yeah, so we've only got 3 parse states now. I'm going to do replacements for parse state equals 4. I'm going to replace those with parse state equals 3 for the current document. And then I will go into the switch case, and we'll say case 3. And then that'll now handle the pound vertex and pound. So that those are just like the rig. Mode 3 is now looking not in the header section or the global section, but in specific shaders. So cool. Good. And shader section parsing. And then I'll worry about fixing all the comments later off stream. That's a little bit of a boring part. Cool. Let's get out of here and let's take a look at the conundrum. So the conundrum is this. Going into the Enterprise GLSL header, I had noticed while I was testing yesterday that if I did this, I take out most of the characters for per camera and just make it per, that everything still worked. And I wasn't expecting that. The way that I had built the UBO binding system, the idea was that you would close out of that. Should probably got to rearrange my window again. Autos, locals, threads, modules. This is all because I wanted to make my memory window be the top window, which was stupid. All right. So the idea is that when you go to set a uniform buffer up, you go to graphics, graphics.h. You would create a uniform buffer using this API, and it would give you a handle. So you'd say, create uniform buffer. You provide it the hash name of the uniform block to associate it with. Then you'd pass it the other details for the buffer, including the size of it, a pointer to the data if you wanted to start by initializing it, whether it was it should be streamable or considered static, like a constant. So the idea is that you would pass the name of the buffer you wanted to work with into that field. And then when you go to bind the shader, Enterprise would take into account the name you gave it and then automatically bind this to the same point as, or bind the uniform buffer to the same binding point as this uniform block. So imagine my surprise when I changed this name and found that everything was still working. So like if this was literally garbage, does it work? Yes, it does. And I know that the buffer is working because if it wasn't, we wouldn't have access to, well, actually that's kind of not exactly true, is it, now that I'm thinking about it? Oh, that's why. Oh my gosh. This actually might not be a problem at all. I just might have been not thinking through it. I am not actually using the these values. I am only using the model view projection matrix, which is set at an EP per draw. So if I set it to garbage, then it doesn't work. Okay, that's what I expected. That's what I expected to happen. Okay, that makes sense. Yeah, so basically GLSL optimizes away uniform buffers that you don't, or optimizes code that you don't use in your GLSL programs. So I wasn't using EP per camera, so it didn't identify a uniform block, I don't believe. Or no, it may have done, but it simply didn't matter that I wasn't binding to it correctly. I do utilize the view projection matrix and the view and the projection matrices for calculating the model view and projection matrix, model view, projection, model view, and just the model matrix in this buffer. But that's actually done on the CPU side. So on the CPU side, I actually store the view and projection matrices and the world position in the in CPU memory, and then I construct the contents for EP per draw. So I guess a better question is then if there's a problem with this buffer, like if I was to comment it out, why isn't it giving me an error? Validate program, OGL program. So if I comment out the buffer, then it does fail to validate. OpenGL will give me a message. Invalid value. Error compiling shader. So it failed to compile, first of all. It failed to compile because the EP matrix MVP is undefined now, because I took out the uniform buffer that contained that that variable. Sampler uniform does not exist text. Okay, and then that also results in a failure to bind the texture to the texture handle in the sample in the fragment shader, which doesn't show here because it's not the one that failed to compile. And we have invalid value now for line for vertex arrays.cpp line 395, where it broke here, because OGL active program is not a valid program. Okay, so that resulted in a failure to compile. But if we were to stop the debugging, go back to the header, bring it back in, and then give this a BS name, it results in a program that does compile, because we're referencing, we just reference EP matrix MVP, which is now included in the header, and it's part of the thing. We reference that here, and it's a totally valid variable. But because this doesn't bind to anything, I don't have an error message. And I'm thinking that I probably should. Because if I was a developer and I was working on some code, like maybe you put your own uniform buffer in the shader for your material, because like things that are not handled by the system would theoretically be parameters that you provide from your material. Then you would want to know why it's not working if there was just a typo. The program will still run and work totally fine, but perhaps there should be a warning when the uniform buffer is not bound to. Should there be? I mean, one of the advantages of uniform buffers is that you can just swap out a buffer, so I can actually like maintain separate buffers in GPU memory to supply a single shader, and then when I want to do another draw call where it's the same shader, same everything, I could just tell it to use a different uniform buffer, bind it to the uniform block, and then it'll just use those values directly from GPU memory, and I don't have to send it new uniform data every frame. But it's totally valid, I think, then to just not bind it. So maybe that's okay. I'm on the fence about that. But I suppose that's that we're actually this is a good thing. Now that I know that that actually wasn't a bug, it was just a mistake on my understanding of how it was supposed to work. I just anticipated that it was going to be required for the MVP matrix to work. I can actually just clear this off. This actually turns out to be a bug. Please simply archive. So I guess that means that we're in good shape. There's just that I really could have used with a warning to tell me why I wasn't seeing a problem before. Or sorry, I should say I really could use with a warning to understand why the binding, to understand that the binding is not occurring. Because it might not be as conspicuous as this. In this case, it's very conspicuous that the buffer is not binding, because if I give it a different name and I go to run the program, I don't see anything at all. But in a material, for example, if the binding wasn't going correctly, if I attempted to bind a like named uniform buffer, then I might not immediately perceive what data isn't loading correctly. You would, so if I was writing a shader for a material, ideally I would be putting all of the data I need for that material within a single uniform buffer, so that I can maintain multiple copies of that buffer and just swap out just bind the buffer I need for a particular material. And if I'm including all of the data from the buffer in a single, or all of the data from the material within a single buffer, then that actually would probably be conspicuous. Like I wouldn't see the only stuff that would load correctly would be the textures, because textures are not part of uniform buffers; they're their own thing. So yeah, I think I'm actually okay with this, with the way that we got it. Cool. So does that mean that I've done everything that I care about today? Done with the vertex and fragment. Yeah, I guess so. I've actually switched to GLM, so I don't need that anymore. There's a number of things that I threw in here that I'm not completely ready to go with. But I accomplished everything I wanted to today, so I'm going to go ahead and end it after 3 hours. Now we've got a rather robust shader system where I can do if I can find the frickin' folder here, I can do header files in GLSL. Those will automatically link over to the application when I'm debugging, thanks to the new command line option, engine shaders dir. So this will point to the correct location while I'm debugging, and then in the shipping copy of the game, it'll look in the correct location for the other. I got user includes now, where I can, in the shader, I can do include this, and specify whatever location in the content directory, like shaders like mat1 or like fong or something. And then that'll look correctly in the content folder instead of in the other folder, and I can write boilerplate code for materials and for any shader type that needs to interface correctly with a system. And where this will become particularly powerful is with prog option, where I can do, tell Enterprise that I support a specific system, and then it'll automatically produce a variance that is used when the system is running and when it's not. Cool. So yeah, I'm gonna go ahead and end the stream. I'm not sure when I'll stream next. My next big goal is not immediately clear. I know that I'm going to need to start writing a basic renderer soon, because one of the next big things I need to work on is starting to construct scenes, and I can technically already do that. I have scene file serialization. I have entities. I have an entity component system that's extensible. But to construct a scene would be a little tedious with just like typing it out in YAML. So I need to start thinking about how I'm going to create an editor for constructing scenes. And that's going to require a lot of thought. So it might be a little while before I'm back on stream. Cool. I hope that somebody finds this VOD helpful if they ever are looking to do GLSL includes, because that's not a language feature and it's just so useful. Take it easy.